right, I'm going to catch up to you guys a little bit here. Let's see. So 0 actually makes this function undefined because of the negative power there, right? So put a little u on top of that guy. So something really kind of weird is happening at 0. You guys might not be any radical, like square root of x is going to have an infinite slope at 0. It's kind of like coming down as like, I got an infinite slope. So that's really what's happening. That's why it's undefined at 0. If I plug in there something less than 1, this is negative. And if I plug in something bigger than 1, then this is positive. Yay. And of course this piece is always positive because x is greater than 0. Or, you know. Okay, I like it. Maybe, maybe, maybe. So that means here it's going down, and here it's going up. So I saw a lot of people putting little happy and sad faces. That doesn't come in until you do second derivative. That's concavity. This is just straight up, where's it going up and down? So it's obviously got a what here? Yeah, so it's got a min. Why obviously? Because it's going down to it and then coming up from it. So it's got to be a low point. When I plug a 1 in, what do I get? I get 1 minus 3. So whenever you're trying to complete a point, you plug it into f. Anything else, you're going to plug it into one of the derivatives. So it's decreasing. This is not too bad, right? 0 to 1, and it's increasing 1 to infinity. Now hopefully, I don't know if you guys took this to heart, what I was saying earlier. Where am I going to start to try to show this? Where exactly will I start to try to show this? I'm going to start with this guy, right? That's the better form for derivative. No product rule required. So if I put down here f prime, and then f double prime, 1/2 comes down, negative 1/2 comes down. The smaller power is the negative 3/2. So I'm going to take out 3/4 x to the negative 3/2. That makes this 1 x plus 1. Now, is everybody cool with that? Is that all right? Okay, I'll take that as a yes. This is where it gets a little. Is this where it gets a little weird, Jeff? Where are my critical points critical numbers just by looking directly at this? 0 and negative 1. What's wrong with him? Not the domain, so screw him, right? In fact, if I try to put a negative 1 in, it freaks this guy out because it's not even in the domain anyway. So be real careful about. That's why domain is like the first thing you look at. It's going to tell you how to make your sign diagrams. It's going to tell you which values to forget about. So my little sign diagram is going to have just 0 out there. It's undefined at 0. I don't care about that part. It's out of the domain. So does my concavity change? No, there's nowhere for it to change. So it's going to be whatever the hell it is. So if I put in any number bigger than 0, what do I get? What sign? Put in any number bigger than 0. Put in 1. 1 to the anything is 1 times 2 is positive. So it's always concave up. It's always happy. Right? Weird little thing. So it's up, 0 to infinity, no inflection points. We kind of knew from the beginning this sucker was going to look a little weird. It's got all those radicals in there. So what about intercepts? What's the x-intercepts? Let's start with the y-intercept. Why not? Y-intercept is easy. You just make x 0. So when you make x 0, you just get 0. Woohoo! What about x-intercepts? What do I need to do to find those? Almost always. So y to 0 and then factor. I like it. So what comes out of here? No. You always take out the one that has the smaller power. Right? So x to the half. So what's left inside? I'm going to take an x to the 1/2 out. X to the... Yeah, just x. I like it. X minus... three. So I get either x is 0 or x is 3. So that, of course, jives with this. And this one is a neat out of nowhere. All right, now if you haven't done it yet, try to combine all that together into a graph. Yeah?
Why is there no inflection point at 0, 0?
So an inflection point means what? What has to happen?
That they come together.
That
Well, the concave.
on one side and the other side, the concavity is different. It's positive on this side. What is it on the other side? There is no other side. Yeah. Is that cool? So that's why that's not an inflection point, because they can't even talk about what's happening on the other side of it. I like it. So try to get that all together into a graph. Oh, shit. So you got your min, right? You got your intercepts. All right. So this one's kind of nice. Not always, but it's a nice trade-off sometimes. When the function and the derivatives are really freaky, there ends up being less happening, which is a nice little balance. Not always. So there's not really a lot happening with this thing. So it's always concave up, which looks right. And it's decreasing, so it's going down. So I start here. And it goes down through the minimum, concave up all the way through, and then there. And if you check it, let's see. Make the window the same. So let's see. -5 to 5, and then -2.5 to 2.5, so it matches with my picture. Jihad! All right, sweet. Say again? Zoom in where?
To the graph, because
Beautiful, I love it. Thank God. All right. You should look at these weird things and go, what the shit? So what is happening right here? Who remembers what's the weird thing happening right there? On our very first sign diagram, we saw something weird happening here with the slope. It becomes infinite. So that becomes a resolution problem for the graph. If it becomes infinite and I take a little step, it changes, it's infinite slope there. So if the graph isn't doing good enough resolution, it's not going to be able to complete this. I don't know have you ever tried, back in pre-calculus, did you try graphing like the top half and the bottom half of a circle? No? Maybe we'll do that. So yeah, I love it. Beautiful suggestion. Let's zoom. I'm going to do zoom box, little enhance from CSIS. Enhance. Because there's freaky shit happening there, and part of your brain should be like, what the shit? Does it have anything to do with this problem? No. But some of you should be like, let me look at this damn thing. Look, oh man. All right, let's zoom in again. All right, it still isn't connecting, is it? Because of the step size, the calculator obviously doesn't do every possible point. That would take an infinite amount of time. So it has a bit of a step size between the inputs it uses. So if I zoom in again, and this time I'm going to zoom in where it supposedly has nothing. So if there really is nothing there, then nothing should show up on my graph when I do this. You guys see that? Supposedly there's nothing there. Let's see if it can handle this. Yeah, sweet. If I keep doing that, it'll keep showing up more. So if I zoom in again, where it looks like there's nothing, there will be something. And part of it is, it kind of is running into this axis, but more importantly, it's the resolution problem. So real quick, just because you can't go through life and never see this shit. What's this? The equation of circle of radius 1. Let's make the radius 4. What the hell? Now, if I solve for y, I'm not going to do all the frickin' steps. You should be able to. You get there, right? So how do I graph that circle? Well, I have to put the top part of the circle in. Where'd it go, Jeff? And then I've got to put the bottom part of the circle in. So look at the problem this has. It's exactly the same issue. You got everything in there? Yes. Let's zoom. Yeah, zoom standard. Doesn't it look like it doesn't connect? Right? What's happening at those edges? What's happening to the derivatives right at the edge? They become undefined, infinite. Same exact resolution problem. That's why it looks like, one thing, it looks like a football because the screen itself is rectangular, right? So it's not going to come out circular. Second thing is it doesn't connect because of resolution issues. It doesn't plug in enough x values to get all the points necessary. If I zoom in and zoom in and zoom in, it'll keep getting a little better, because when I zoom in, there's less points for it to worry about. It puts more points in. Does that make any sense? If I zoom in, it only has to worry about the points, and so I can put the step size becomes smaller and smaller, it's more and more and more precise, but it's never gonna get there. Zoom in, zoom in, it's just never gonna get there. Okay, enough of that. Sorry. I was excited because that's the kind of thing that should spur you to go, what the shit's going on? Instead of, that problem's done. Let's do next one. Okay. Is everybody cool with that? Any questions about that besides that weird thing? Okay, so let's do, you hate handouts. Definitely me. For other reasons. Let's do the same thing on this one. Let's do the front together, and I'll let you guys do the back, and we'll see how much time we got left. So now I'm throwing some more stuff into the mix here. So what's the domain of this bad boy here?
-51.
I like it. So x not equal to 1. Yay. Sorry. But you're right. You're right. You're right. Sorry.
You would accept that in the test, right?
Totally, yes. Unless I say intervals,
Okay.
you know. But you're good. Don't get me wrong. That was beautiful. But this says the same thing. I'm always one for simplicity. Unless I'm not. Now, take a minute and see if you can do this. I should have shown you, I started with this. I started with this form, did the derivative, because I wanted to make something where you could actually factor the top to find the critical numbers. So I did all the work and I figured out what A, B, and C, and D had to be so that this would work out nice. Well, whatever, Jeff. Who gives a shit? So go ahead and show that, and then try to get the critical numbers. You don't have to try to cram it all in there. This is just a handout. You can do the work wherever you want to. The easiest mistake in that work is right here. Because the quotient rule is drew the top times the bottom. Of course, top first. Minus, drew the bottom is 1 times the top. So minus the entire top then. So that's got to be minus, minus. And that's why I tell you what the derivative should be. Because if you do that mistake, the graph is going to look funkadelic. All right, so that's verified. How many critical numbers are there going to be? You guys are like, dude, slow down. I don't know. Maybe tell me, what's the most obvious critical number from this? I don't have to do any work. What's the most obvious critical number from this? 1. Because where's one place where critical numbers happen is where the derivative is undefined, and it's undefined at 1. So critical number, what I got so far is x equal 1. The other 2 critical numbers, of course, come from where this sucker is equal to 0, and how do I make a fraction equal 0?
0 to the top.
Yeah, 0 to the top. I love it. So 2x squared minus 4x minus 16 equals 0. Divide by 2. So I get my other 2 critical numbers. Is that cool? Yeah, skip the other way. Is that not cool? Ah. So what are my critical numbers? I got 1. What else?
-4 and 2.
Nope. 4, -2, right? Just got to make these 0, so it's going to be the opposite side. Okay. All I always get at least one person that wants 0 to be a critical number for every problem. 0 is not a critical number here, is it? Do I use the idea of 0 to find? Yeah, of course you do. But 0 isn't necessarily a critical number all the damn time. So I got -2, 1, 4. It's 0 at -2 and 4, and undefined at 1. And now, thankfully, I can throw 0 in. Now, look, multiplicity still works even if it's a ratio. So what's the multiplicity of 1? It's an even multiplicity. And the other ones are going to be first degrees, right? They're going to have a multiplicity of 1. Is everybody able to see what I just said? If I did factor the top, both of those, and we did, didn't we? They were both multiplicity 1. So the only one that's going to not change sign around is 1, because it comes from a multiplicity of 2. So if I put 0 in, where did I put my... I'd rather use this guy. That's good. If I put 0 in, I get negative over positive, so I get negative. It's going to stay the same sign on the other side of 1. It's going to change sign there and change sign there. Let's double check. If I put a 5 in there, I get 50 minus 3. I get positive over positive, positive. Okay, that sounds good. And again, I know I've said this before, but if you don't like multiplicity at all, don't use the damn thing. Put -3 in there, 0. Put 3 in there, put 5 in there. Check each region out manually. So it's increasing from -infinity to -2, or from 4 to infinity, and it's decreasing everywhere else. So up, down, down, up. Does it have a maximum? Yeah, so -2, comma, something or other. If I plug a -2 in, oh, jeebus, let's see. That'll be 8 minus 32, right? -24. What was it again? -2? -24 over -3. Oh, it comes 8. Is that 8? I think so. You guys, of course, don't like helping me out on those. I'm sorry. And then the minimum happens at 4 because it goes down and then comes up. Please let that be easy. Goes down, comes up, must be a minimum. 4, comma, something. Let's see. 32 plus 64, right, is 96 divided by 3 is 32. That's weird. Let's see. Well, I mean, it's not impossible, but it's really not likely. Oh, no, yeah, totally. Okay, let's go with it. I forgot there's really exceptionally freaky things happening at 1. So why am I concerned there for a second? I forgot what I got now. What did I get? 4, 32, 96 divided by 3, 32. I got 32 here. So why does that seem wrong? Yeah, but what's happening at 1? What is up with 1? It was not in our domain, and for a rational function, what does that mean? What do I put at 1? Oh shit, that's the location of a asymptote. I love it. I thought you were calling me something, but you're an asymptote. Okay, so right here there's going to be a wall. So look, here's a very simple way that a minimum could be higher than a maximum when I have an asymptote, right? This minimum is bigger than that maximum. That more than likely is what's going to happen here. Okay. And again, if you hit that point, the problem, you can just graph it to just kind of reassure yourself, as long as you're not copying shit from the graph. All right. I like it. So when you have vertical asymptotes in a problem, it can just pick up on one side and go to the other side, so anything could happen then. I like it, I like it. This is a lot of fun. This is very, not obvious that it's going to just come out to this. Has anybody tried this one yet? Try this one. So start here, take a derivative, and I am telling you it will come out to be this. Believe it or not.